Number one, points A and B lie on a circle with center O and radius r centimeters, where angle AOB is 1.5 radians. This is shown on the following diagram. This diagram, a sector. The area of sector OAB is 48 centimeters squared. Find the value of R. R is radius, is OB is R and OA is R. Hence, find the perimeter of sector OAB. So the question A, we are going to find R first, the radius first, and then we're going to find the perimeter. OB plus OA plus AB, AB or BA. All right. A. According to this information, that area of sector is 48 centimeters squared. So this area is 48 centimeters squared. To calculate the area, we have to use area of the formula. Area of this sector equal 1/2 multiply r squared multiply angle, this theta. Theta in radius 1.5. And according to this information, that area is 48 centimeters squared. So we can substitute 1.5 into this theta, becomes 1/2 multiply r squared multiply 1.5 equal 48. Or r squared equal 48 multiply 2. This is 2 divided by 1.5. And if we calculate, this result is 64. So we can determine r equals square root 64 is 8 centimeters. Next, B. B is perimeter. So we need to find BA, arc length BA or AB. This arc length. OB or BO equal OA 8 centimeters. So this 8, this is 8. So we need to find arc length, and after that 8 plus 8 plus arc length, and we can determine the perimeter. How to calculate arc length? The formula is radius multiplied by the angle. The angle in radians is 1.5. Radius is 8, so 8 multiply 1.5, and it is 12 centimeters. So arc length, if this is the sector, this is 12, this is 8, this is 8. So we can determine the perimeter. The perimeter 8 plus 8 plus 12. It is 28 centimeters. That's number one. Number two, two events A and B are such that probability A is 0.65, probability B is 0.45, and probability A union B 0.85. Find probability A intersection B, and find probability A action given B action, right? So we can use the formula for the probability of the union. of two events A and events A and B. The formula is probability A union B equal probability A plus probability B minus probability A intersection B. According to this information that probability A union B is 0.85, probability A is 0.65, and probability B is 0.45, and yeah, we are going to find this probability A intersection B is 0.5. We are going to calculate this is 1.1 minus probability A intersection B, or we can write in probability A intersection B equal 1.1 minus 0.85. And if we calculate, the result is 0.25. That is the probability of A intersection B. Next, question B is probability A action given B action. So the formula, we are going to using the conditional probability formula. The conditional probability A action given B action equal the probability A action intersection B action divided probability B action. Okay. And so we need to find probability A action intersection B action first. This probability. The probability of A actions intersection B action equal 1 minus probability A union B. And it is 1 minus, according to this information, part A, this is 0.85. 0.85. It is 0.15. This probability is 0.15. Now probability B action. Probability B action is 1 minus probability B, and it is 1 minus probability, according to the information, probability B is 0.45, and it is 0.55. All right, let's recalculate. So it means the probability A given B action equal 0.15 divided 0.55. Okay, and it is 3 divided by 11. 0.2727, so on. So in fraction, the solution is in decimal, this is the solution. Next question. Prove that 3n plus 2 squared minus 3n minus 2 squared is multiple of 12. So if multiple, it means we are going to prove that this expression divisible by 12. Okay, divisible by 12. Okay. 3n plus 2 squared, I'm going to expand, becomes 9. 9n squared plus 2 multiply 2 times 3, 12. And plus 4 minus 9n squared minus 12 squared, 12n squared. Okay. And Oh no, 12n, only 12n, sorry, without square, okay. And plus 4, right? So becomes 0 because 9n squared minus 9n squared, and it becomes 12n plus 4 plus 12n minus 4, 0. So 12n plus 12n equal 24n. It is, this expression is divisible by 12. This is divisible. If divisible by 12, it means we can state that 24n is a multiple, sorry, multiple of 12. Number 4. The following diagram shows triangle ABC where AB equal 4 centimeters, BC equal 6 centimeters, AC equal 5 centimeters, and angle ABC equal 2 theta. This angle, 2 theta. Question. Find the exact value of cosine theta, giving your answer in the form p square root 2 over q, where p, q element of integer positive, right? So we are going to use in the cosine rule. Cosine 2 theta, if you look this triangle, okay, cosine 2 theta equal AB squared plus BC squared divided AB squared plus BC squared minus AC squared divided by 2 multiply AB multiply BC. So if we substitute into this rule, it becomes 4 squared plus 6 squared minus 5 squared divided by 2 multiply 4 multiply by 6. 16, 36 minus 25 divided 48. Okay. 27 over 48. Simplify becomes 9 over 16. Next, we are going to continue with a trigonometrical identity. A trigonometrical identity says that cosine, uh, trigonometrical identity correspond to this this statement, okay, according to the question. So trigonometrical identity of cosine to t is 2 cosine squared theta minus 1. Or we can rearrange this formula, okay, becomes 2 cosine squared theta equal cosine 2 theta plus 1, like this. And the next step, cosine squared theta equal 1/2 of cosine 2 theta plus 1. It becomes 1/2, according to this information, that cosine 2 theta equal 9 over 16. So 9 over 16 plus 1. So we can say it becomes the same denominator, 9 over 16 plus 16 over 16. So 1/2 25 over 16. Okay. And then it is 25 over 32. That means this is cosine square theta. It means cosine theta is square root 25 over 32, or square root of 25 is 5. This is square root 16, square root 2. So it becomes 5 over 4 square root 2. Okay, let me look at the question first. According to the question, we are going to set the answer becomes like this, the form p square root 2 over q. It means p is the numerator and q is the denominator. So p equal, we can state that p equal 5 and q equal 4. That one. Number 5. For a particular arithmetic sequence, U10 equals 16 and S25 equal 100. Find the value of k such that uk equals 0. Okay. So 10 equal, according to the formula of arithmetic sequence, is a plus 9d equals 16. Okay. For a, we can write a plus 9d equals 16. This is the first equation. And according to this information, that S25 equal 100. So S25 formula is, according to the formula, becomes 25 over 2 multiply 2a plus 24d, because 25 minus 1, so 24. And according to this statement is 100. Now, we're going to multiply by 2. It's going to be 25 to a plus 24d to 100. After that, divided by 25. Divided by 25 becomes, this equation becomes 2a plus 24d equal 8. And this is the second equation. So the first equation and the second equation, through the first equation and the second equation, a plus 9d equals 16 to a plus 24d equal 8. Now we're going to eliminate, a, multiply by 2, multiply by 1. So it's going to be 2a plus 18d equal 32. 2a plus 24 d equal 8 minus, cancel a, and this is minus 6d, 24, d equals 24 over minus 6, and it is minus 4. Next, substitute d into d equals minus 4 into a plus 9d equal 16. Okay. So it becomes a plus 9 times minus 4, 16. A equals 16 plus 36 equals 52. Okay. That is A and D. And the next step, we're going to substitute A equal 52 and D equal minus 4 into, according to the question that we are going to find K. Okay. We're going to find K, which UK equal 0. UK equals 0. It's A plus K minus 1 times D. And if I substitute 52 and minus 4 becomes 52 plus K minus 1 is minus 4 equals 0. So 52 minus 4K plus 4 equals 0. So 52 plus 4 equals 56. 56 minus 4K plus 0. I'm going to continue here. I'm going to continue here. Okay. 56 and K equal 56 divided by 4. It is 14. Next question. Number 6. Solve 2x squared minus 15x plus 18 less than 0. This is inequality. 2x squared minus 15x, 18 less than 0. So we need to set this becomes equation equals 0 because we're going to find the value of x. This is A, B, and C. So x1 and x2 equal minus of minus 15 becomes 15 plus minus square root minus 15 squared minus 4 multiply 2 multiply 18 divided by 2 multiply 2. 15 plus minus square root 225 minus this is 144 by 4. So 15 plus minus square root 81, 4. So 15 plus minus 9 over 4. So we can determine x1, 15 plus 9 over 4. It is 24, 4, 6. And x2 is 15 minus 9 over 4. And this is 6 over 4 or 3 half. So 6 and 3 half. And we can determine the solution area of x. This is 3 halves, then this is 6. So the solution area is this one, is this area. Because of the equation is this is less than or equal. Which one? Okay. If you substitute a number here between 3 half and 6, for example, if you substitute 2, 2 position between 3 half and 6. If you substitute 2 here into this expression, 2x squared minus 15x plus 18 less than 0, uh, I would like to substitute 2 squared 2. If you substitute 2 into this inequality, you can find that minus 94, the calculation is, if you calculate this is minus 94, less than 0. This is correct. This statement is correct or true. If correct, it means this area is the solutions area between, so the interval area between x greater than 3 half less than 6. This is the solution area. So the area of x. Yeah. B. The question B. The function f is defined by fx plus square root of this expression to x squared minus 15x plus 18, where x element a real number and x less than or equal k. Find the greatest value of k for which inverse of this function exists, justifying your answer. For fx to have an inverse, for fx have an inverse, it must be 1 to 1. Okay, 1 to 1 function. So fx must be 1 to 1 function. Yeah. But if you look this function fx equal to x squared minus 15x plus 18, this function is not one-to-one function. Why? Because if you sketch this function is a parabola. Right? It's a parabola, open upwards parabola. Okay, so this function is typically not one-to-one function. Yeah, this is open upwards because if you look, the value of coefficient of x squared is the positive as the positive number. Okay, so now to make the function becomes one-to-one, we must restrict the domain. The domain becomes the increasing or decreasing part of parabola. This function with open upwards of parabola, it has decreasing, okay, interval decreasing. I would like to writing here this function function fx, okay, is decreasing on interval for x element of minus infinite to 3 half, like this. So the maximum is 3 half. It's decreasing. How about if 6? If 6 and positive infinite, that is increasing. So we are going to find the maximum number, maximum number of an interval. So this is the maximum number. So we can state that the greatest value is 3 half. So next question, number 7. Consider the function f(x) equals secant x minus pi 4, pi over 4. For x, this is domain. X for domain x interval 0 to pi half. Determine the range of f. Okay, so this is the domain of this function, domain of fx. So I would like to convert to change fx equals second x minus pi quarter. You know that if second theta, it is 1 over cosine theta. So second x minus pi quarter, it is 1 over cosine x minus pi quarter, like this. This is fx. And the domain x from 0 to pi half, right? Based on the domain, we are going to find the value of this denominator, cosine x minus pi quarter. So at x equal 0, x plus 0, this expression becomes cosine 0 minus pi quarter, and it is equal cosine minus pi quarter. It is square root to half. And at x equal pi half, so cosine pi half minus pi quarter, it is 2 quarter minus 1 quarter. It is cosine pi quarter, and it is as well equal to half. So the minimum value of cosine this this statement or this expressions, the minimum value. I will write it here, the minimum value, because we are going to find range, so we need to find the minimum and the maximum value. The minimum value of this expression, cosine x minus pi quarter, it occurs at which one? At square root 2 half. This is the minimum value. And the maximum value occurs of cosine x half occurs when x equal pi half, pi quarter. So it means it is 1 because cosine 0 equal 1, right? Since the second function is the reciprocal of cosine, so the range we can state the range of fx, uh, the range of fx we can determine, okay, through this when cosine x minus pi quarter equal 1, so we get fx equals 1 divided by 1. Look the function, 1 over cosine, sorry, 1 over cosine, this 1 over 1. Yeah, so 1 over 1, it is 1. Now, when cosine x minus pi quarter equals square root 2 over 2, so we get fx equal 1 over square root 2 over 2. It is 2 over square root 2. Multiply square root 2 over square root 2. It is square root 2. So therefore the range of fx, uh, the range of fx for domain x from 0 to pi half is one fx greater than or equal 1, less than or equal square root 2, according to this result and so on. Part B. Question. The region bounded by the graph of y equal fx, the x-axis and the lines x equals 0 and x equal pi half is rotated 2 pi radians about the x-axis. Find the volume of revolution generated, right? We're going to find the volume by integral 0 to pi half of secant x minus pi quarter square dx. The integral of this expression is tangent x minus pi quarter. How do I substitute pi half and 0 into this expression? If we substitute, it's going to be pi tangent. If this is pi half minus pi quarter, it is pi quarter minus. If this is 0, it means becomes tangent minus pi quarter. So it's going to be pi times 1 minus 1. This is 2. So the pi is equal to 2. So the volume equal to pi, this one. Okay. Next question, number 8. The following diagram shows 2 points, A and B. This point A and B, such that vector OA equal A, vector OB equal B. The diagram. The point P lies on AB, this on line segment AB, so that vector AP equal lambda vector AB, where lambda interval 0 to 1. Show that vector OP equal 1 minus lambda A plus lambda B, right? OP, it means 1. I would like to create a strike. This is a strike line, actually, a strike line OP. Okay. OP. So vector OP equal OA plus AP. Okay, vector. Okay. Okay. So OP equal OA and AP plus AP. Right. According to the information that OA equal A and AP is lambda AB. Okay. And it is equal A plus lambda AB is B minus A, look this diagram. This is B, this is A. OB is, factor OB is B, factor OA is A. And after that, A plus lambda B minus lambda A. And then factorize 1 minus 1A and lambda A, 1 minus lambda multiply A minus plus, sorry, this one, lambda B. This is OP, factor OP, right? B. It is given that A equal 1, modulus A equal 1, modulus B equal 2, and A dot B is 1/4. In the case that factor of P is perpendicular to factor AB, find the value of lambda. P is perpendicular to AB. That means OP dot AB equals 0 because of perpendicular. So OP is equal this expression 1 minus lambda A plus lambda B. AB is 1, B minus A equals 0. And more space, right? And after that, multiply. B multiply 1 minus lambda A becomes 1 minus lambda AB, 1 minus lambda A squared. If we multiply lambda B squared minus lambda A B equals 0. And it's going to be substitute A 1, B equal 2, modulus B equal 2, and this modulus A dot B equal 1/4. Substitute into this equation. If you substitute, it becomes 1 minus lambda 1/4 minus 1 minus lambda 1 because 1 times 1. And this is lambda multiplied by 4, 4 lambda. AB is 1/4, so 1/4 lambda of equals 0. So that multiplied by 4. If we multiply by 4, it's going to be 1 minus lambda minus 1 minus lambda 4, 16 lambda minus 1 lambda. Okay, minus 1 lambda equals 0. Okay. And it becomes 16 lambda minus 1 lambda is 15, 15, and this is plus 4. Okay, I will have to write it like this first, plus 4 lambda equals 0. Okay, minus lambda 1 lambda plus 4 lambda 3 lambda 16, 18. So 18 lambda 1 minus 1 plus this is plus equal, this is minus 3. Wait, oh, this is 4 here actually. This is 4 minus 4 because minus 1 times 4. Okay, becomes 18 lambda equals 3 and lambda equal 3 over 18. This is 1/6. So lambda equal 1/6. Next question, number 9. Prove that tangent theta minus pi quarter equals sine 2 theta minus 1 over cosine 2 theta minus 1 to cos theta to cosine 2 theta, where theta not equal this one, this expression, this fraction. Hence, or otherwise solve sine x minus 1 over cosine x equals square root 3 for x interval 0 to pi. Right? A. Tangent theta minus pi quarter. I would like to change, okay, becomes this is actually according to the trigonometric identity that it is equal tangent theta minus tangent pi quarter over 1 plus tangent theta multiply tangent pi quarter. After this is tangent pi quarter is 1. So we can writing becomes tangent theta minus 1 over 1 plus tangent theta times 1 here because this is 1. Okay, and it's going to be tangent theta minus 1 over 1 plus tangent theta, 1. Okay, and the next step, tangent is sine theta over cosine theta. So I would like to writing becomes, wait, here, becomes sine theta over cosine theta minus 1 over 1 plus sine theta over cosine theta. And I would like to set becomes the same denominator, sine theta over cosine theta minus cosine theta over cosine theta over cosine theta over cosine theta plus sine theta over cosine theta. So the numerator and denominator set becomes the same denominator. So it's going to be, this is sine theta minus cosine theta over cosine theta. Then it is cosine theta plus sine theta over cosine theta. This is sine theta, cosine theta, this one. Okay. And the next step, I would like to multiply sine theta minus cosine theta over cosine theta multiply cosine theta. So from division becomes multiply. You have to set like this, plus cosine theta, and divide it. And this is sine theta minus cosine theta over sine theta plus cosine theta. So we are going to multiply with conjugate of the denominator, sine theta minus cosine theta, sine theta minus cosine theta. Comes, if we multiply, it's going to be sine squared theta minus 2 sine theta cosine theta plus cosine squared theta over sine squared theta minus cosine squared theta. 1. So the numerator, because sine squared theta plus cosine squared theta is 1 minus 2 sine theta cosine theta over sine theta, sine squared theta minus cosine squared theta. I would like to write thing like this minus, uh, wait, minus cosine squared theta plus, sorry, cosine squared theta minus, because I will using the trigonometric identity theta like this, okay, and can continue. It becomes minus as well 2 sine theta cosine theta minus 1 over this is minus this expression equal cosine 2 theta. Okay, so minus cosine 2 theta. So minus divided by minus equal positive, and this expression 2 sine theta cosine theta is sine 2 theta times 1 over cosine 2 theta. So tangent theta minus pi quarter equal sine 2 theta minus 1 over cosine 2 theta. Part B, solve sine x minus 1 over cosine x equal square root 3. Okay. Part B. If x equal to theta, so the implication theta equal x over 2 or x half. So tangent, according to this expression, is question that tangent theta minus pi quarter, it is tangent. Now substitute theta equal x half into this expression, becomes tangent x half minus pi quarter, like that. And according to the equation that it equals square root 3. Right. Tangent, we're going to find arctangent. Arctangent, I'm writing here. Arctangent square root 3, it is pi third 1. So tangent theta minus pi quarter, it equals tangent pi third. So it means theta minus pi quarter equal pi third, or theta equal pi third plus pi quarter. 4 plus 3, 7. 7 pi, 7 pi over, wait, this one, oh, sorry. Supposed to be, this is x half, because this expression is x half, okay. So 12 here. So We can determine x equal, because this is 2, multiply by 2. So 7 pi over 12 multiplied by 2, it is 6. So x equal 7 pi over 6. So this is x. Number 10, consider a cylinder of radius 4r and height h. A smaller cylinder of radius r is removed from the center to form a hollow cylinder. This is shown in the following diagram. Our lengths are measured in centimeters, so this is the cylinder. The total surface area of the hollow cylinder in centimeters squared is given by S. The volume of the hollow cylinder in centimeters cubed is given by V. Show that S equal 30 pi r squared plus 10 pi r h. Okay. So the cylinder consists of the outer area, outer lateral area, and the inner lateral area, area of lateral outer and area of inner outer, outside and inside this. Okay, so we're going to calculate the area of lateral outer and area of lateral inner. Okay. At outer 2 pi multiply the radius outer is r plus 3r, 4r times h. It is 2 pi multiply 4r because r plus 3r. If you look on the, you can evaluate the cylinder. Multiply by h, it is 8 pi r h. And for inner, the area lateral inner 2 pi multiply by r inner multiply h 2 pi multiply r multiply h 2 pi r h. Okay, lateral outer and lateral inner. Next, top area. For the top area is area on upwards. Okay, we are going to calculate this area. Okay, this area. And after that, this area. Base area same with the upward area. The top area, base area same with base area. The top area equal pi multiply 4r squared, because the radius is 4r, minus outer, the small cylinder is pi r squared. It is 16 pi r minus 1 pi r equal 15 pi r squared. Base area same with top area. It equal 15 pi r squared. That means S equal outer plus inner area lateral outer plus area lateral inner uh, plus top area plus base area. So equal 15 pi r squared plus this top area plus base area, 15 pi r squared plus 8 pi rh plus 2 pi rh equal 30 pi r squared plus 10 pi rh. Okay, so S equal this one. The surface of the cylinder is this one. B, question B. The surface area of the hollow cylinder is 240 pi centimeter squared. Show that volume equal 360 pi r minus 45 pi r cubed, right? So if this surface equal 240 pi, we're going to show that volume is 360 pi r minus 45 pi r cubed. Okay, so if 30 pi r squared plus 10 pi r h equals 240 pi. We are going to find h first, and this is divided by pi, becomes 30 r squared plus 10 rh equal 240. So 10 rh equal 240 minus 30 r squared. So h equal 240 minus 30 r squared divided 10 r, or h equal by 10, 24 minus 3 r squared over r. That's 1. Now substitute h equal this fraction into volume. Volume is large cylinder minus the small cylinder. Okay, I need more space. Large cylinder, we can calculate pi. The radius is 4r, 4r squared multiplied by h, pi r squared h. That is a small cylinder. And this is 16 pi r squared h minus 1 pi r squared h, 15 pi r squared h. After that, substitute h equals 1 into this h. 15 pi r squared, 24 minus 3 r squared over r. R divided by r equal 15 pi r times 24 minus 3 r squared. Okay. And it is 15 multiplied by 24 is 360 pi r, okay, minus 15 multiplied by 3, 45 pi r cubed. This is volume. Next question, part C. Find the find an expression for dphi dr, differential of the phi. This is phi, so dphi dr. This is part C. Dphi dr is differential of this expression is 360 pi minus 3 times 45, 135 pi r squared. So this is the differential of volume. Next question, D. Next question. The House cylinder has its maximum volume when R equal P square root 2/3. Find the value of P. P element of integer positive, right? Volume will be maximum if the R equals 0, if derivative equals 0. So it means 360 pi minus 135 pi r squared, I mean, pi r squared equals 0. And divided by pi is going to be 360 minus 135 r squared equals 0. And after that, you're going to find r becomes, it is 135 r squared equal 360, and r squared equal 360 divided by 135. So r equals square root 360 over 135, or square root 8/3, or it is 4 times 2, it means 2 square root 2/3. So if you compare with the question, we are going to find P. So the volume when R equal P 2/3, so P equal 2. P equal 2 is 1. Next question. Hence, find this maximum volume giving your answer in the form Q pi square root 2/3, where Q is element of integer. Okay. Part E. If R equal 2 square root 2/3, we are going to substitute R into the volume formula. 360 pi R minus 45 pi R cubed. So substitute this R into this expression, becomes 360 pi times 2 square root 2/3 multiply 45 pi 2 square root 2/3 cube. 2 times 360 is 720 pi square root 2/3 minus 45 is a 2 cube 8, and then if square root 2/3 cube is 2/3 square root 2/3, 720 pi 2/3 minus 45 times 8 times 2/3 is 240. This is pi here. Pi square root 2/3. And 720 minus 240 is 480. Pi root 2 third. So, number 11. A curve is given by the equation y equal e power to x minus 1 over e power to x plus 1 with x elements of real numbers. By applying the Hospital's rule, or otherwise, show that limit x approach to infinity e power to x minus 1 over e power to x plus 1 equal 1. So it's limit uh, x approach to infinity, right? According to L'Hopital's rule, so limit x approach to infinity e power to x minus 1 over e power 2x plus 1 based on the L'Hopital's rule that we are going to find the derivative of the numerator and the derivative of denominator, right? So it's going to be limit x approach to infinity, derivative of e power to x minus 1, it is 2e power to x. This is the derivative of this numerator. And derivative of this denominator, e power to x plus 1, is 2e power to x. So it is 1 because 2e power to x divided by 2e power to x equal 1. B. Part 1. Show that dy dx equal 4e power to x over e power to x plus 1 squared. According to the question that y equal e power 2x minus 1 over e power 2x plus 1. To find the derivatives, so we are going to using the substitution method. Let ux equal e power 2x minus 1. So this is ux, the numerator, and the denominator is phi x. So it means derivative of u du dx to e power 2x. And phi x equal e power 2x plus 1. And dv dx equal 2e power 2x. dy dx we can gain through the substitution rule that phi x multiply du dx minus ux multiply dv dx over px squared. After that, substitute this information, ux, du dx, px, and dv dx is going to be e power 2x plus 1 times 2e power 2x minus e power 2x minus 1 to e power 2x divided e power 2x plus 1 squared. And after that, expand, multiply 2e power 2x multiply e power 2x becomes 2e power 4x plus 2e power 2x minus 2e power 4x plus 2e power 2x over e power 2x plus 1 squared becomes 0, and it is 4 e power 2x over e power 2x plus 1 squared. This is dy dx, or the first derivative. And the next question, part 2. Show that 1 minus y squared equal dy dx. Part 2. Right. The function is y equal e power 2x, e power 2x minus 1 or e power 2x plus 1. So it means y squared equal e power 2x minus 1 squared divided e power 2x plus 1 squared. And 1 minus y squared is 1 minus this fraction, e power 2x minus 1 squared over e power 2x plus 1 squared, or 1 minus y squared equal, we are going to set becomes the same denominator, e power 2x plus 1 squared, 2x plus 1 squared minus e power 2x minus 1 squared over e power 2x plus 1 squared. So 1 minus y squared becomes e power 2x plus 1 squared minus e power 2x minus 1 squared over e power 2x plus 1 squared. This is x. And next, 1 minus y squared equal, now we're going to expand this, e power 4x, e power 4x plus 2 e power 2x plus 1 minus, this is e power 4x minus 2 e power 2x plus 1, okay, over e power 2x plus 1 squared. So 1 minus y squared. Now we are going to cancel this one as well. Becomes 2e power 2x plus, because minus and minus becomes plus, so it is 4e power 2x over e power 2x plus 1 squared. So if you look, the first derivative, dy dx is this one. This is dy dx. Okay, 4e power 2x over e power 2x plus 1 squared. So we can state this equation is 1 minus y squared equal dy dx. 1. Next question, part C. By using implicit differentiation and the result in part B2, this one, show that the second derivative equal to y cubed minus 2y. Okay. So according to this information, that dy dx equal 1 minus y squared. Now we are going to using the implicit differentiation. to find the second derivative. It becomes 0, and based on implicit differentiation, this is 2y dy dx. Well, minus because it is minus. Or dy, the second derivative equal minus 2y dy dx is this one. This one minus y squared. So substitute 1 minus y squared into this equation becomes 1 minus y squared. So the second derivative, dy, the second derivative equal multiply minus 2y minus 2y cube plus, because minus plus times minus. And it's going to be the second derivative equal 2y cube minus 2y. This is part 1. Part 2. The question is, hence find an expression, the third derivative in terms of y. The third derivative. Okay. This is the second derivative. 2y cubed minus 2y. So it means the third derivative. We can determine by implicit 3 times 2, 6y squared minus 2 dy dx. And after that, substitute dy dx equal 1 minus y squared. It's going to be 6y squared minus 2, 1 minus y squared. Multiply 6y squared minus 2. After that, minus 6y to the power 4 plus 2y squared. 8, because 6 plus 2, 8y squared minus 6y to the power 4 minus 2. So this is the third derivative based on implicit method. Next question. By using your results from parts B and C, find the Maclaurin series for e power e to the power 2x minus 1 over e to the power 2x plus 1 up to and including the term of x cubed. So we are going to find the first derivative, second derivative, and third derivative to solving it. The Maclaurin series, D. The function y equal e power 2x minus 1 over e power 2x plus 1. dy dx, the first derivative, dy dx is 4e power 2x over e power 2x plus 1 squared. So this one, the first derivative. The second derivative now, the second derivative is 2y cubed minus 2y. So we can find in terms of x, if we substitute y into this expression, and the third derivative in terms of y, you can you can change into the terms of x if you substitute y into this expression. And the third derivative is 8y squared minus 6y to the power 4 minus 2. This is the third derivative. According to Maclaurin series, the Maclaurin series, that y equal y 0 plus dy dx dy dx 0 times x plus the second derivative 0. Substitute if x equals 0, x squared, the third derivative 0, and this is x cubed. Right. So it means Maclaurin series becomes y0 if, okay, if x equals 0 first, okay. If x equals 0, so y0 equal, y0 equal 1 minus 1 over 1 plus 1 because y is e power 2x minus 1 e power 2x plus 1. So e power 0 equals 1, 1 minus 1 equals 0. So this is 0. And the first derivative, the first derivative dy dx, which x equals 0, it is 4 power 4e power 2 times 0, so 4 times 1 equals 4. And e power, better if I write here, e power 2 times 0 like this. Maybe you will confused. So it is e power 2 times 0, 0 plus 1 squared. So it is 4 divided by 4 equal 1. And the second derivative, if x equals 0, the second derivative is 2y cubed minus 2y. Okay. Look that if y is 0, it equals 0. It means this is 0. So 2 times 0 minus 2 times 0, it is 0. And the third derivative is 8y cubed minus 6y 4 minus 2. Y, if y 0, it equals 0 according to this information. So substitute into this. Third derivative becomes 8 times 0 minus 6 times 0 minus 2 equal minus 2. So the Maclaurin series becomes the Maclaurin y equal y0 is 0, this is 0 plus 1 times x, because this is 1, okay. Dy dx is 1, okay. And the second derivative 0 times this one, 0 times x squared, 0, and the third derivative is 1 minus 2, minus 2, okay. Okay, minus 2 times the x cubed over 3 factorials like this. Yeah, this is 2 over 2 factorials one. This is over 1 factorial. This is x squared over 2 factorials, according to Maclaurin series. So it's going to be 0. No need to writing 0. Yes. This is x. This is 0. Minus 2. This is, it means divided by 3. X cubed over 3. So this is the Maclaurin series with x cubed. Number 12, consider the equation c power 4 equals 16i, where c element of complex set numbers. This one complex number set. The equation has 4 roots. C1, C2, C3, C4. Where ci equal r cosine theta I plus I sine theta I, which r greater than 0, and to pi greater than theta 4 greater than theta 3 greater than theta 2 greater than theta 1, and theta 1 greater than or equal 0. Find C1, C2, C3, and C4. Part A. According to the information that Zi equal R cosine theta plus I sine theta. I would like to find R as the modulus of 16i. It is 16. And the argument is theta equal pi half. And the polar form of 16i is 16 times cosine pi half plus I sine pi half. So this expression is I. So 16i equals 16 cosine pi half plus I sine pi half. If you calculate, this is 0 and this is 1. So 16 times I. Right. Now we're going to use the Moivre's theorem to find the roots of 16i, the roots of 16i. And the formula is zk equal n root of r times cosine theta plus 2k pi over n plus I sine theta plus 2k pi divided by n. Right. And according to the information that n equal 4, or n equal 4, it means we have that r equal 16. If r equals 16, so the form of this one, the form of n root of r, it becomes 4, the fourth root of 16, and it is 2. So it's 1. We are going to using this form equal 2. Okay, next. And the argument of roots is theta plus 1 2k pi over 4, okay, over 4 which k equals 0, 1, 2, 3, because n equals 4. So supposed to be this n, but n equals 4, so this is divided by 4. Now let's start with k equals 0. For k equals 0, we can find z1. Okay. Z1, according to the information, is 2 times cosine pi half plus 2 times 0 pi divided by 4 plus I sine pi half plus 2 times 0 pi over 4. So Z1 equals 2 times cosine pi over 8 plus I sine pi over 8. That is Z1. As we continue to Z2, for k equal 1, Z2 equal 2 times cosine pi half plus 2 times 1 times pi divided by 4 plus I sine pi half plus 2 times 1 times pi over 4. It becomes 2 cosine. This is 2, it means 2 plus 2 times 2, 4 plus 1 is 5. So 5 pi over 8 I sine 5 pi over 8. This is Z2. Next, for k equal 2. For k equal 2, C3 equal 2 times cosine pi half plus 2 times 2 pi over 4 plus I sine pi half plus 2 times 2 pi over 4, and it is 2 times cosine, 2 times, it is 4, 8 plus 1, 9. Okay, cosine 9 pi over 4 plus I sine 9 pi over 4. Well, that is C3. Next, for k equal 3. For k equal 3, C4 equal 2 times cosine pi half plus 2 times 3 pi over 4 plus I sine pi half plus 2 times 3 pi over 4. And it's going to be, this is Z4. To cosine, 2 times this is 6. 12 plus 13. 13 pi over 4 plus I sine 13 pi over 4. So C1, C2, C3, and C4 already. All right. Let's continue to the next question. The roots C1, C2, C3, and C4 form a geometric sequence. Find the common ratio of the sequence expressing your answer in Cartesian form. B. In a geometric sequence, the ratio between consecutive terms is constant number. So we can express the roots as like this. The roots C2 equal R times C1. Okay. Or C3 equal R times C2. Or C4 equal R times C3. I'm going to using this equation to find R. R equal C2 over C1. So R, according to our previous solution, that Z2 is 2 cosine 5 pi over 8 plus I sine 5 pi over 8 over Z1 is 2 cosine pi half pi over 8, pi over 8 plus I sine pi over 8. Well, so 2 divided by 2 equal 1. So it's going to be cosine 5 pi over 8 plus I sine 5 pi over 8 over cosine pi over 8 I sine pi, sorry, not 5, but pi over 8. I'm going to fix first. But now we recognize that both of the numerator and denominator are in polar form. The polar form is so cosine like this, cosine 5 pi over 8 plus I sine 5 pi over 8 as well, the denominator. So we can simplify the ratio using the formula for dividing complex numbers in polar form, for example, like this. If cosine, this just for my notes for the next step, cosine theta 1 plus I sine theta 1 over cosine theta 2 plus I sine theta 2. It is cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So we get R equal cosine according to this note, this rule, cosine 5 pi over 8 minus pi over 8 plus I sine 5 pi over 8 minus pi over 8. And it is cosine 4 pi for 8 minus I sine 4 pi over 8. So it's going to be cosine pi half plus I sine pi half. Cosine pi half, it is 0. So it is 0 plus I times this is 1. Sine pi half is 1. So it is I. 0 plus I is I. So R, the conclusion, R equal I. So Next question, C. The roots C1, C2, C3, and C4 are represented by the points A, B, C, and D, respectively, on an Argand diagram. Plot the points A, B, C, and D on Argand diagram. Okay. C. For C1, C1 is 2 cosine pi over 8 plus I sine pi over 8. The real part of Z1, the real part of Z1 is 2 cosine pi over 8. And this is, if you calculate, the result is 1.85. Meanwhile, the imaginary part of Z1 is 2 sine pi over 8, and this is 0.77. So the coordinates on Argand diagram is in the first quadrant. This is after the first quadrant is the Argand quadrant like this. Okay, and this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Z1 located here on the first quadrant, right? Next, this is for Z1. For Z2, and this is A. This is for A. So A coordinate, whether if I write in here, 1.85, 0.77 on Argand diagram. This is imaginary axis, and this is real axis. Okay, for Z2, Z2 equal 2 cosine 5 pi over 8 plus I sine 5 pi over 8. And the real part of Z2 is 2 cosine 5 pi over 8. And if you calculate this, the result is minus 0.77. And the imaginary part of Z2 equal 2 sine 5 pi over 8. And if you calculate, the result is 1.85. And it's located B, this is B, B coordinate minus 0.77, 1.85. And it's located on the second quadrant. Next, for C3. Okay. For C3, 2 cosine 9 pi over 8 plus I sine 9 pi over 8. The real part of Z3 is 2 cosine 9 pi over 8. And if you calculate, the result is minus 1.85, while the imaginary part of C3 is 2 sine 9 pi over 8. And if you calculate, the result is minus 0.77. So coordinate point of C is minus 1.85, minus 0.77. Next, for C4. is 2 cosine 13 pi over 8 plus I sine 13 pi over 8. So the real part of C4 is 2 cosine 13 pi over 8. And if you calculate, the result is 0.77. I need more space. So we'll scroll down first. And imaginary part of C4 is 2 sine 13 pi over 8, and it is minus 1.85. So coordinate point D, 0.77, comma, minus 1.85. And coordinate point D located in fourth quadrant. Right. Now, we're going to sketch an argon diagram. Okay, this is imaginary axis, and this is the real axis. Uh, 1, 2. 1, 2. 1, 2, 2. Right. The first A is 1.85. A is coordinate point 1.85 and 0.77. B is minus 0.77, 1.85. C is minus 1.85, comma, minus 0.77. D, 0.77, comma, minus 1.85. And if you sketch this on argon diagram, this A, 1.85 around here, 0.77 around here, okay? This is A. After that, B, so minus 0.77 over here, 1.85, yeah, over here. Okay, and the angular separation becomes 90 degrees or pi half. So the angular separation. Next, C is minus 1.8 is 1 here and 0.77 over here. And it will become the strike line actually, the point, coordinate point D. Sorry, C, this one, not D. C, and then D 0.77, 0.77 here, and it's 1.85. Okay, the angular separations pi half. So next question. Equation phi to the power 4 equal a plus bi, where phi element of complex number set, and a b element of rational number has roots. C1, this is reflections of C actually, but I would like to say this as conjugate. Conjugate of C1, conjugate of C2, conjugate C3, and conjugate of C4. Determine the value of A and the value of B. value of A and B. The key idea is the key idea is conjugate okay, Ci power 4 8 equals Zi to the power 4 conjugate. Okay. And it equals 16I conjugate. Because C because Z equal 16, and Ci equals 16I. Or if conjugate, it means it is minus 16I. Zi to the power 4 is it's equal A plus B, A plus B, probably BI, which I equal 1, 2, 3, 4. What? So it means Zi to the power 4 equal minus 16I. If you compare with this equation, so we can state that A plus B I equal minus 16I. So A equals 0 and B equal minus 16. So this A equals 0 and B minus 16. Next question. E. The midpoint of AB is AX, and the midpoint of BC is BX, the midpoint of CD is CX, and the midpoint of DA is DX. And midpoint, it means, wait, sorry, I'm going to show you this. The midpoint of BA, of AB. AB is the midpoint, okay. Around here, this is AXN, and BC around here, this is BXN, but we are going to focus on this one, on AXN. Okay, let's continue the question. Okay, consider the equations W power P equal 2 to power Q, where W element of complex number and PQ element of integer positive. 4 of the roots of W to the power P equal 2 to the power Q. 4 of the roots. 4 of the roots. Okay. Are represented by the points AX and BX and CX and DX, and find the least possible value of P and the corresponding value of Q. Part E. The points AX and BX and CX and DX from a square inscribed in a circle and square vertices on ABCD. Right, so the argument or the angles of square vertices are A. A has an argument of 0 degrees, or it is 2 pi. B has an argument of 90 degrees, or it is pi half. C has argument of 180, or pi, and D has an argument of 270 degrees or 3 pi half. And now about argument of a accent one, because we are going to find on a accent. Argument of a accent, it is 0 degrees plus 90 degrees divided by 2, and it is 45 degrees or pi over 4. Fine. And we can determine argument of the accent, argument of C accent, argument of D accent, but we just find argument of A accent based on the questions. And the argument of W1 equal pi over 8 plus pi over 4, and it is 3 pi over 8. Pi over 8 is the angle between the center of the circle uh, and A accent. Yeah, the center of just now I show you the diagram. Now we are going to find AB. AB. Look this diagram. I'm gonna show you the diagram. This is AB. This is 90 degrees, or so we can find AB based on Pythagoras. This is 0 to A2 and 0 to B equal 2 as well. Since the points are evenly distributed on a circle, we can calculate the distance AB as the diagonal of a square inscribed in a circle with radius 2. That's why. So that's why origin to A2 and as well origin to B equal 2. So it means AB equals square root 2 squared plus 2 squared. Square root 8 or 4 times 2, 2 square root 2. And then we can determine A to A accent because I would like to sketch here on argon, okay, like this and like this. Okay, this is A and this is A accent. This is B. Okay, A accent is a point, midpoint between A and B. So A to A accent is half of AB, 1/2 of AB. So it means 1/2 of 2 square root 2. So it becomes square root 2. So A accent equals square root 2. And OA accent equal modulus W1, and it is square root 2 as well. So if you create, this is right angle. So OA accent equals 0 to equal O, not 0, sorry, O to A accent. Then N is equal square root 2. So it means W1 equal square root 2 cosine 3 pi over 8 plus I sine 3 pi over 8, or it is square root 2 6 3 pi over 8. This one. Now, how about P and Q? Based on the statement on the question that W power P equal 2 power Q. W is this one, square root 2. So square root 2 power p equal 2 power q. Or we can writing as 2 power 1 half p equal 2 power q. That means 1 half p equal q. Or p equal 2q. Now, regarding the smallest number, the smallest value. The smallest value for p and q are determined by the symmetry of the roots. So, since we have four distinct roots, four distinct roots, so the smallest possible value for p, smallest possible value for p is 16. If p is 16, it means we can determine q, and q equal 1/2 of p, 1/2 of 16, and q equal 8. So p equals 16 and q equal 8.